Welcome candidates to this live session for the course metal cutting and machine tools. I would like to invite you to ask me whatever question comes to your mind, whatever queries, kindly share with them with us, so that we can discuss on those matters, and all of us will be gaining more knowledge and sharing it through this discussion. So, while questions are you must be preparing questions and uploading them. In the meantime, I will just put one or two points to you. There will be a handout distributed with the questions, and I would like you to read this handout very carefully. Yeah. Characteristics of the three steels in relative manner: ductility, strain hardening, thermal conductivity, hardness. So, you will be having different kinds of work materials, and these work materials might be mild steel, they might be medium carbon steel or stainless steels, etc., etc. They will be having their different values of ductility, as you have mentioned, strain hardening, thermal conductivity, etc. And while machining them, the material properties which affect cutting cutting ability, etc., those will depend. For example, when you are measuring the forces, they appear through the shear strength of the material, dynamic yield shear strength, and this yield shear strength depends upon the normal stress which is applied, and generally it is given an expression that sigma is equal to sigma 0 plus k into tau s is equal to tau 0 plus k into sigma n. So, that way it depends upon the strength, and there are other aspects that you have mentioned. Hardness, generally when you are trying to make steel harder, it is done with the help of adding carbides. Okay. How do we get carbides? You can have certain metals which are added. So, these additives, I will give you an example, say high speed steel. Instead of mild steel, high speed steel is used as a cutting tool material. What does it have as its material inside? What kind of percentage composition does it have? It has 18% tungsten, then 4% chromium, 1% vanadium, and this also has 0.7 to 8% carbon, and the rest is iron, and these alloying elements tend to form carbides which are very hard. Tungsten carbide, as you know, it is extremely hard, and they tend to increase the hardness of the ordinary iron material that we have by means of these additives. You might be having molybdenum added to increase hardness, and that is a competing element in comparison to tungsten. When there was an embargo on in the Second World War and tungsten was not available with Germany, they tried to substitute tungsten with the help of molybdenum. Okay. I have another question here waiting, which is master line concept. Master line concept, I think I have defined very in detail in the lecture, but still I will try to share the concept with you. That is, when you have the reference plane Okay. When you have the reference plane slanting towards one side, that means if the reference plane is parallel to the bottom plane of the tool, if the tool is say sitting on a horizontal surface, if you have let me take the help of this one, if you have this as the bottom plane on which the tool is placed, suppose I am placing the tool here, that means the bottom plane of the tool is horizontal. This is a horizontal plane, bottom plane of the tool, and the rake surface of the tool might be slanting. So, that ultimately two planes, just as two planes have an intersection and cause a straight line, okay, have a straight line as an intersection. So, just like that, the rake surface and the bottom plane might be having an intersecting line, I mean intersection in the form of a straight line. If they are parallel, there will be absolutely no intersection. Okay. All rake angles will be coming out as 0. There will be no master line, or rather you can say that these two will be meeting as the definition of parallel lines and parallel planes, these will be meeting at infinity. So, we understand that master line is the intersection, say master line for rake is the intersection between rake surface and this bottom plane. If these two intersect, that means the rake surface has a slant, and this slant is different in different directions. In which direction will this slant be the maximum? Perpendicular to the master line, and that is the direction in which the slant of the rake surface, that means the rake angle is maximum in the direction which is perpendicular to the master line. That is how we get the maximum rake. Okay. In the same way, you can have master line for clearance angle, I mean a principal flank, and master line for auxiliary flank. So, concept of master line is like this: always start with the bottom plane of the tool and consider it to be horizontal. With respect to that, if the rake surface is parallel, then there is no rake angle in any direction, rake angles are all 0. If it has a slant, they will have an intersection, and that is called the master line. With respect to that master line, we can say a number of make a number of observations. I will tell you one observation, and after that I will talk about other questions. Suppose I find that the projection of the what do you call it, the main cutting edge and the master line for rake, they are parallel. It must be giving some information to us about the tool geometry. What is it? When does the master line for rake and the main cutting edge on the xy plane become parallel? I will not straight away give you the answer, because if you think, you will definitely get it. I might be giving you a hint. Does it require that one of the tool angles has to be 0? If so, which one? So, please think about it. Master line for rake is parallel to the main cutting edge in the xy plane. If so, does it require one of the tool angles to be 0? If so, which one? I hope this helps. Let me talk about other points. On production increase in industries. In industries, if you go for production increase, there can be a number of ways in which you can do it. I will just elaborate one or two. For example, people will say, you want to increase production, go for higher cutting speeds. So, you take your high speed steel tool and start employing higher cutting speeds, but there will be a big failure after that, if not catastrophic failure. The problem is, when high speed steel is used at very high speeds, say over 30 meters per minute while cutting mild steel, okay, you will have a drastic reduction in the tool life. So, one way to increase production in industry is to use better cutting tools, okay, which can operate at higher cutting speeds, okay, and still have a high tool life. Let me give you an example. If you have cast carbides Okay. You can have stellite, okay, a cobalt based cutting tool which is cast. Why am I giving so importance on the word cast carbide? Because carbides, you know, they are refractory materials. That means they require quite a high amount of energy input for melting. So, if you spend so much time for melting some material and then pouring it into a cavity and then casting it, it won't be, you know, very meaningful. So, that is why the solution is that do not melt these carbides, take small particles of carbides and, you know, pack them together by a process called sintering with a packing material. What kind of packing material are we talking about? Say cobalt, okay, cobalt, nickel. So, tungsten carbide particles, you know, caked in a binding material called cobalt, okay, and that will give you a very hard material which is called tungsten carbide with cobalt as the binder, about you know 4% cobalt and rest tungsten carbide. And this one, when it goes through sintering and hot isostatic pressing etc., it is good for cutting materials at a very high speed. So, improving cutting tool material so that you can employ very high speeds. What other methods? You can have reduction of non-productive you know handling time. You can have reduction of handling time in order to speed up production. Now, what do I mean by that? I mean that suppose you are having you know 50 jobs to be drilled, same type of drilling. So, you have a drilling machine in which there a single spindle drilling machine and you are drilling one job, putting it down, loading another job, drilling it, putting it down. This takes a lot of time. So, you can have paralleling of operations, multi spindle drill. So, multi spindle machines are very much popular in increasing production. Okay. What else? Tool changing time. You can reduce tool changing time. Tool changing time can be you know considerable. If you consider say regrinding a tool and bringing it back and using it again, instead of that use indexable inserts. Just in a flash you can change the you know cutting edge once it has collapsed. So, inserts can be available with multiple edges or multiple points and they can be used, and tool changing time, regrinding will be eliminated and tool changing time will be least. Okay. So, this can be done. Lots of other methods are done. I will give you a sort of summation method. That means, this will help me in sharing this particular idea. Instead of the job going from machine to machine, why should the job go from machine to machine? There might be a number of operations which are required. So, if say 8 operations are required and for that suppose you have to go to 4 different machine tools, you will be requiring quite a lot of time in order to you know shift the job from machine to machine. And for that the concept of machining centers, turning centers and then you know turno milling centers, they have evolved. That means, instead of the job moving from machine to machine, let all the machines come together, get you know transformed into a machine which has lot of facilities, and so shifting the time required for shifting the job is you know reduced. So, all these ways like improving cutting tool material, then using multiple spindle machines, using reducing tool changing time, then paralleling of operations, then what do you call it using the concept of machining centers, and many other points are there. I will just note it down. If I can have small notes on available, I will share it with you by uploading. Okay. So, all these things can improve production rate in industries. There is another question that we have, difference between Norton tumbler and meander drive. You will find that in my lecture I have shown you a Norton tumbler. A tumbler means you know something in a pail which contains water. Okay. Okay. So, conical shaped object, that is that Norton tumbler, and the meander drive a river meanders, that means a river goes this way, that way, and the meander drive looks like that. The meander drive, the main function is to basically divide the RPM available by a factor of 2, then a factor of 4, then a factor of 8, like that. And the Norton tumbler gives you a number of output rotations per minute which are very close, separated by a definite ratio. For example, you might be having a Norton tumbler in which there will be a series of gears having 32 teeth, 36 teeth, 40 teeth, like that. In a series they will be reducing gradually, and the output of the Norton tumbler is a number of rotations per minute in quick succession. Now, how do we utilize this? Let me see if I can utilize the pen in order to draw it. Yeah. So, what happens is, suppose I have pitches to be cut 1, 2, 4, 8, 16. This thing will be obtained from a particular part of the machine, meander drive, and in each you might be having 9, 10, 11, 12, 13, not 13 perhaps, if I remember correctly it is 14, etc. So, from this particular column of rotation, columns of pitches that we can cut on the lathe, this is obtained from the meander drive. And all these will be obtained from the Norton tumbler, which looks like this. Sorry. This is the tumbler, and the Norton connects with this one in a shifting lever. Okay. This goes shifting, this goes on shifting. You will find that I have given you animated pictures in the lecture, so that you will not be having much difficulty in understanding it. This one gives you all these pitches. Okay. That is successively, if you connect it up here, if you connect it up here. Now, where does this go? This generally goes to the meander drive here, meander drive, and after that it connects up with the lead screw. If I remember correctly, all these are in my lecture. So, if you are interested to find out which is for what, this is obtained by Norton tumbler and this is obtained by meander, because if you notice, the meander drive gives you output by factor of 2, 1, 2, 4, 8, 16 and 8, 9, 10, 11, 12, 14. So, this way you can easily find out which is shifting by a factor of 2, this one. So, this one must be obtained by meander. Okay. So, let me go back, erase. Okay. I will be waiting for further questions from your side. In the meantime, let me just tell you that in the handout which you will be getting during exam, I have specifically mentioned that if you have questions in which some formula or some expression is required, as much as possible I have shared those formula and expressions with you, so that you do not have to memorize anything. Generally, when I am defining all such terms in the formula, I might not be specifically defining each and every term, because you are coming across it so many times through through assignments, through studies, through preparation, etc. So, if I write that P z is equal to T s tau s into cos eta minus gamma 0 divided by sin beta into cos beta plus eta minus gamma 0. So, I will be expecting what is gamma O, orthogonal rake. I will be expecting what is what is beta, shear plane. So, I might not be defining them. These things you have to know, but the expression you do not have to memorize. So, students please feel free to ask me anything. It might be within the syllabus. You might also ask me out of interest which is not within the syllabus. It does not really matter. If possible, I will be answering you now. If not possible, I will try to upload, so that both of us gain by the increase in knowledge. So, the time that I have before you send me further questions, let me quickly tell you something about the questions structure. There will be 70 questions in sorry, not 70, there will be 45 questions in all. 35 questions will be carrying 2 marks. Within these 2 marks, I mean within these 35 questions, we will have some questions which are called instant recall type. The moment you come across it, you will be knowing the answer. I will give you an example. Suppose I say that what do you call it, a cylinder can be machined on, and then I say the options I give you lathe, and then I give you another option hacksaw. So, like this you will instantly know that the answer should be lathe. So, you do not have to do any thinking also. So, this sort of questions you can expect within 35. I will be giving at least say 10 to 15. The rest of the questions will be having small calculations or a small bit of thinking on the part of the students, but nothing nothing in detail. So, these 2 questions of 2 marks each, 35 of them make up 70 marks. The rest 10 questions that I have in hand, they will be of 3 marks each, and they will be somewhat more difficult than the rest. In what way? I might be asking you to solve a particular engineering problem, the result of which will be ultimately the application of a formula. So, it will, I have tried my best to avoid direct formula plugging questions. What is formula plug-in question? It means that you are given a formula, you are told that see depth of cut is this, feed is this, then dynamic yield shear strength is this, etc., etc. So, find out what is PZ. I have tried my best to avoid such straightforward questions. 1 or 2 might be there. So, you might be given a situation in which the solution ultimately requires the application of some formula, say Taylor's tool life equation, you have to apply, or suppose like this. Okay. So, as this is a metal cutting and machine tools course, please understand that there will be quite a lot of weightage definitely from metal cutting, because it is almost 50% of the course. Apart from that, there will be a lot of machining questions dependent upon machining. What sort of questions? I might be asking you questions from gear shaping, I might be asking questions on gear hobbing, from ultrasonic machining, from abrasive water jet machining. So, you might say, how do I prepare then? Please look at my lectures. I have given some time for computer controlled machines. I have given some time on non-traditional machines, gear cutting machines, milling machines, lathes, etc. All of them, all such discussions are going to be relevant when questions are concerned. So, do not only prepare for metal cutting, please prepare for questions on the other aspects as well from machine tools. You might say, where do we get questions for practice? Please try to access, those who have joined in late, please try to, this I have already discussed, please try to access questions from previous run assignments. Where do you get them? It should be available on the forum only, I mean on the website of this course only. If you find it is not available, you please get in touch with me immediately. I will ask NPTEL to upload them. There is one answer to the one question that we discussed just now. If master line is parallel to the base plane, then rake angle must be 0. I will just do a bit of correction here. What I meant was, if the master, if the reference plane is parallel to the base plane, planes can be parallel. So, if the reference plane is parallel to the base plane, there is no master line, or rather the master line appears at infinity. So, that we cannot see it. In that case, all rake angles must be 0. That means, if you cut the rake surface, okay. So, so just a moment. I should just write it down. Maybe I made a mistake in stating the problem. Please just wait. Achha, is it possible to type here? Oh my God. Okay, I will use the pen. So, I should say this should be what I was trying to say. If reference plane is parallel to the, sorry, just a moment, let me pick up the rubber. Right, I should write, if rake surface is parallel to bottom plane. Maybe I did not speak this way when I was talking. If the rake surface is parallel to bottom plane, there is no intersection. Okay. Generally, the rake surface is tilted, and that is why it cuts the bottom plane. So, if the rake surface is parallel to the bottom plane, there is no intersection, and therefore, it indicates all rake angles are 0. This is what I wanted to say. I am extremely sorry if I made a mistake in framing the answer. Maybe I was saying over and over again, if the reference plane is parallel to the bottom plane, that is always so. If the rake surface is parallel to the bottom plane, there is no intersection, and it indicates all rake angles are 0. Okay. Now, let us come back. So, if the rake surface, if the master line for rake is parallel to the main cutting edge, that was the question that I had asked. Let me see whether anyone has given any answer to that. Yeah, somebody has mentioned that if master line is parallel to the base plane, then rake angle must be 0. Okay, I will. This is not exactly what I said, but let me say this, that first of all, I have already told you about rake surface being parallel to the bottom plane. Then what happens? After that, if the master line is parallel, master line for rake, if it is parallel to the main cutting edge projection on the xy plane, then what does it indicate? So, that actually indicates that something must be 0, and it probably indicates that something has to do with the cutting edge. Okay. So, the what do you call it, the inclination angle, is it 0, or the orthogonal rake angle, is it 0? Orthogonal rake angle is not 0. If it had been 0, then it must have wouldn't have had an intersection. The rake angle, in the orthogonal rake being 0, it wouldn't have met it that way. But if these are parallel, the inclination angle must be 0. There is another answer question query which is come. In Taylor's tool life, assignment 3 question 4, please explain it. First of all, I do not know whether the answers to the assignment 3 they are already okay. I will come to this. In first question was in Taylor's tool life equation, assignment 3 question number 4, please explain it. I am not very sure whether the answers to the assignment they are already out or not. If they are not out, I cannot explain it, but I will keep this in mind. Okay. The assignment is not in front of me just now. So, let me just copy it down. Assignment 3 question 4, I will explain it, but I will first make sure that it is not it is already displayed, the answers are all displayed, then only I can discuss it. Okay. And since it is not in front of me, this information, I cannot do it just now. Next question which has appeared is that kindly explain about auxiliary orthogonal rake with a sketch. So, let us try it out. All right. So, here I have a cutting tool. When I am talking of the main cutting edge, this is the main cutting edge, main cutting edge. And if I want to take a view at the orthogonal rake, that means main connected with the main cutting edge, I take a perpendicular section. So, if this is the auxiliary cutting edge, I must be taking a perpendicular section of this one. So, if you take a perpendicular section of this, it will appear somewhere here perhaps. Auxiliary cutting edge, perpendicular to that, take a section of this type, okay. Take a section of this type and look at it here. You will be noticing that this is auxiliary orthogonal rake. Okay. I hope this explains what you are asking for. Acha. Since there is a question on Taylor's tool life, I will I cannot discuss it just now because I do not have the assignment in front of me and I do not know whether it is already answers are displayed, but I will quickly find it out and respond to you over forum. Let me quickly discuss one or two things about Taylor's tool life, that is regarding Taylor's tool life. Sometimes the constants need to be found out, sometimes constants will be provided and I will give you a problem in which you have to apply this Taylor's tool life sorry, and solve some problem. Okay. Please remember that V is the cutting speed expressed in meters per minute and T is the tool life expressed in minutes, and N and C are constants. Achha. Coming back, so if you allow me, I will just remind you the two processes that we have discussed in detail. While I am waiting for your questions, the two processes that I have discussed in detail about gear cutting, rather three processes. One is milling of gears, both spur gears and what is that, the second one, spur gear and helical gears. milling of helical gears and spur gears, and using ordinary indexing and differential indexing, then cutting of spur gear on the gear shaper, cutting of spur and helical gears on the hobbing machine. I would like you people to study these things very carefully, use the reference books that I have provided you during the discussions, and this will be extremely useful. Questions might also be asked on different parts of these machines. For example, I might be asking a question on a particular gear train, that is such and such gear train is used for controlling the number of teeth, and I will set you a small numerical problem on that something of this type. So, those who have come in late, please feel free to ask me some question, I will wait for you. Okay. So, there one question is coming about reference books. I am extremely sorry if this book is not available. There are some other books as well, but they are even older. They are even older, and this book is not available in e-book form. I am afraid there is no other book which has all these things in detail in one single place. That means, this book that I am following some other books also. This book has practically everything, starting from metal cutting. It has given first of all a very good treatment in metal cutting, and it has also discussed about the different machine tools that I have discussed, and of course, non-traditional machining to a large extent I have dependent upon manufacturing science by Ghosh and Malik. I do not know whether that has an e-book, but I really am extremely sorry I cannot help you in this regard. If the e-book of this reference is not available, there is no other book which I can think of which has all these details in one place. So, please solve this problem somehow, I cannot help you. But I will approach the author and tell him of this problem. That is, there appears to be a very good demand for e-book, and so he will think, but definitely he cannot give you in time. Yes, apparent coefficient of friction. Let me draw a quick picture. When this is the cutting tool and say this is the rake surface, this is the rake surface in the orthogonal plane. So, I write pi o. The chip is coming down this way. When the chip is coming down this way, as it is a case of orthogonal machining, so orthogonal cutting is taking place. As it is a case of orthogonal cutting, I can claim that the complete force system, that means the forces that are occurring in cutting, they are confined in this particular plane. That is the main thing which is claimed in case of orthogonal cutting. In orthogonal cutting, since the chip does not deviate away from this plane, its velocity is completely contained in the orthogonal plane. Therefore, all the forces which arise, they are on the orthogonal plane only. So, the full forces, they are here. So, I can draw the force somewhere like this, say for example, this is the force I claim. Merchant circle diagram allows us, since we know that the in a circle, if this is the diameter, any two pairs of lines, which you join like this, these are going to be right angles. This we know. So, I contain it inside a semicircle, and then I say that I can find out the components of this force in any two directions which are mutually perpendicular by simply going up to the circumference of the circle, right angle like that. So, this way, if this be, let me clear it up a bit, clear this, right. This is the circle and this is the resultant force. So, the resultant force can be resolved in these two directions. One is this, one is that, Pz, Px. It can also be resolved if the chip is going this way in the direction of the chip shear plane. So, I can have this as one force and this is another force, Ps, Pn. In the same way, I can say, since the whole force system is here, I can also derive it with respect to a tangential force to the chip tool interface and a force normal to it, and these exactly correspond to this direction. Extend the rake surface and join it here, right angle. So, this must be the frictional force F and this must be the force normal to it, and they together balance the cutting forces. So, the chip is going down, rubbing against the surface and creating frictional force, and this force is pressing the chip down on this particular surface, the normal force. So, if I represent the cutting forces in these two directions by resolving in these two directions, it gives me a sort of, this ratio F by N gives me a sort of friction coefficient, and that is why it is referred to as apparent coefficient of friction. Okay? That is resolving the force in the direction of flow of chip and perpendicular to it, finding out their ratio, which we claim to be the apparent coefficient of friction. Is it really I am measuring by some device the frictional force? No, I am not measuring it. Am I measuring the force normal to the surface? No, I am resolving the resultant force in those two directions. If you say how are you getting the main resultant force? For that I am using a dynamometer, etc., etc. So, everything is indirect. So, that is why we call it apparent. Okay. Achha, let us go back to the question sheet. So, the answer to this is, from the merchant circle diagram, find out F and find out N and take the ratio F by N, that will give you the coefficient of friction. So, we are having quite a active live session, and I would like more people, more students who have logged in late to come up with whatever questions come to their mind and share those questions with us, so that we can have a very fruitful discussion. And regarding reference books, those who have logged in late, I am extremely sorry, the e-book that you are asking for of the textbook that I am following, that is not available, but I can perhaps help you in one regard. That is, you can study the NPTEL lectures which are available of that particular author. Okay, let me write it down on the whiteboard. Please follow this. If you do not have Prof search the internet with keywords NPTEL metal cutting and put in some very relevant term, for example, say what do you call it, merchant circle diagram, merchant or merchants, whatever. Try out with different keywords and then give PDF. This will most probably give you what you are searching for. That is, Professor A.B. Chattopadhyay had posted his lectures on metal cutting and machine tools long back to give you an idea of the time span, maybe 25 years back. So, those lectures are still surviving on the net, and these keywords NPTEL colon metal cutting, then merchants or whatever, you can give different types of chip reduction coefficient, or maybe you can give lathe or milling or whatever, and then give PDF. Okay. So, most probably you will get the PDF form of his lectures together with figures, everything. So, I will do the same thing. I will also, when I go from here, I will search, and if I can find out the internet address for these lectures, I will share it with you. Okay. So, I did not know that you people generally go for the internet for studying instead of going for hard copies. So, I assume the sharing of this book name will be enough, but since it is not, I will definitely share this information. So, let us go back to the main question page. Okay, Yogesh Panchal wants to ask me something. Okay, reference of Chattopadhyay, will it cover all machine tool portion? It will cover gear cutting. It will cover, for example, milling. I have taken the help of a book called Raghuvangshi, Workshop Technology by some M. Raghuvangshi. I found it to be very good in milling. And then gearboxes, feed gearboxes, etc. I have taken the help of a number of books, and among which A.B. Chattopadhyay's book was very relevant. So, A.B. Chattopadhyay's book will definitely cover metal cutting. It will cover gearboxes of machine tools. It will cover gear hobbing, gear shaping. What it will not cover is non-traditional and CNC. It does have coverage of non-traditional and CNC, but I have not referred to that book while preparing my lectures. I have mainly referred to say Amitabh Ghosh and some lectures which are available on the net, similar, that is, if you give NPTEL, PDF, AWJM, you will get some notes on abrasive water jet machining that you can consult. Okay, let us see some more questions coming from some of you. Okay friends, so we have had a very fruitful session, and since I think most of the questions that you had in mind we have already discussed very successfully. I have got very good feedback. I know exactly what you want, like assignment 3 question number 4 you want to get it explained. I will go back, find out whether the questions have already had their answers shared. If the answers are out, I can definitely discuss it. If the answers are not out, I cannot discuss it just now. So, I will get an opportunity as early as possible. If I can share the answers, I will do it immediately. Secondly, I understand that you need soft reference books, I mean textbooks, the soft varieties, and I will quickly find out whether Professor A. B. Chattopadhyay's notes I can retrieve on the internet, and I will immediately share with you these notes, so that you can make the maximum use of it. So, thank you very much, and I sincerely hope that the suspended exams will be held very soon. I wish you the best of luck. Thank you very much.